This is Jeon, and now I'm going to talk about the code for the maze and the robot. In our code, we have three classes: maze, robot, and efficient. On my part, I will explain maze and robot. At the class maze, we have three functions: maze constructor, main, and goal function. For the maze constructor, it shows the given maze. In this sample maze, it has 30 rows and 100 columns. And in here, X is for the exit, and the robot will be located in the first row and the second column. So the robot will be located in here. And the go function, it has string parameter, which is the direction where the robot will move. When the go function executes once, then it will always increase the step and also print out the direction. By the given direction, it will move by followed direction, and it will compare with the sample maze. So in here, if if it is exit, then it will return win. So in here we compare with the x, and the step will increase and also return the string win. And when we compare with the dot, then only the step will be increased and return false. And if the robot can move, then it will move to given direction and return true. Main is for the running the code and make a robot class to call navigate, and it will print out that how many steps that robot tried and show the rows passed and show the walls that the robot found it. For the robot class, navigate function will generate the maze and also generate the efficient. Efficient class will be explained after the robot class. Inside the while loop, it will iterate unless the result is win, which means the robot finds the exit. When we decide the direction, it should be random to be decided first so that we have to make the random number 0 to 1. Direction has 4 ways: up, down, left, and right. So it is divided by 4 and each gap is 0.25. So until 0.25 is up, and until 0.5 is down, and 0.75 to left, and 1 to right. After checks the random number equal to the go function, and it will go to the efficient class.
Practice process to find the exit gate will be accomplished by the efficient class, which is just below the robot class. In the efficient class, there is a constructor. In constructor, they got some robots starting coordinate and map size. Based on the map size, the efficient constructor will create the visit array, which is a 2D array and consists of this just space. And the starting point will be checked as 0 in the visit array. If the navigate function, they randomly decides the direction, that direction will be checked that is true, that is the optimal or non-optimal. If there's optimal, the efficiency check function will return true, and if that is non-optimal, the efficiency check will return the false. If the efficiency check return true for a certain direction and robot move on to that directions, that direction and that coordinate will be checked that is war or space. If that is war, the visited array check that coordinate as a dot through the pass check force. And if there is a space, the visited array will be checked 0 through the pass check true. And we can say that our code is implemented as a brute force algorithm because we just make every possible conditions in efficiency check. So every condition check the direction is optimal or not optimal. There are 3 main conditions to find that is optimal or non-optimal. The firstly, if the robot tried to move on to the previous coordinate, at times we just say that we just return false and we just decide that it's the waste of step. For example, the robot tried to move on to the up direction. However, robot's previous direction is down. It means the robot down and up and down and up. So we just decided that is kind of a waste of step. And to implement that conditions, we implement linked list, which is a path class, in the efficient class. And second condition is if the robot just tried to move on to the war, even though that war is already visited and robot already know that it's war, that times we also return force. So the robot cannot move on to that coordinates. And final condition is if the robot just try to move on to some coordinate that is the robot already visited, even though the around the other coordinate is not visited yet. That times also the robot cannot move on to that directions. So because of that condition is this condition is cause some loop the robot in the maze. So in our code, the robot should move on to the new location.
Now I'll run the code. The result will show that it will print out what all direction that the robot choose and print the exit coordinate. So in here, 23,87 is located here that the robot found the exit, and the steps to reach the exit gate is 3,575. And it also print out the maze that the robot travel. So dot is the wall, and 0 is that the robot moves. This is the maze that robot has checked the maze. So every time I run the code, the result will be always different. Now the step is 2,478. On this time, the result is 14,036.
And we are going to explain the correctness and efficiency of our code.
My name is Bina. I'm going to talk about the time efficiency of this program. To test the time efficiency, I added several lines of the code, as I bookmarked on here. This code exists only for the testing in this time, and this code worked to show clear time contrast between different tries. This code run the program 1,000 times. It also indicates how long it takes for the program to complete and their average, minimum, and maximum times. I will run this code for now. Maybe it takes some times for 1,000 time tries. Okay, for now, the program completed the run. Can you see this screen? There appears the additional information I mentioned earlier. The average time to complete this program is 15 milliseconds, and the maximum and minimum times are 126 milliseconds and 3 milliseconds. And this time list shows the time taken for each trial. So when we set the rows and columns of the maze to N and M. As you see the graph, this one is our time efficiency graph. And according to the proof formula, the O and M has the same result as O n squared in big O. And in this graph, the red line shows O n squared. If you look at the red line, you can see that when the size of NM increases, the over time also increases proportionally. After this, Sangha will talk about the correctness of our program.
Hi, I'm Sawa. I'm going to talk about the correctness of the program. To evaluate the program, I had some rules on the program to observe the ranges of the steps for 1,000 runs. So I set tries for 1,000 and I run the robot for tries. So here I set the program to run robot for 1,000 times, and the step count array will store the number of steps for 1,000 runs. And I made two integer here to count up the range of the steps. If the robot finds the path within 10,000 steps, the integer 10,000 will increase. Otherwise, the integer 50,000 will count the number of steps when the robot finds the path over 50,000. And I set the robot to find the path on the sample maze from the instruction which we used to prove the correctness on the report as well. So this is the sample maze. So when I run this program, as it needs to run 1,000 times, it takes a bit of time. Then we get the result. The program shows the recorded map of the sentence. So this is the recorded map from the last run, as the program need to display the recorded map whenever the robot finds the path. So look at last three sentences here. The program displays the list of steps, and this list has 1,000 tries for each run. For these runs, as explained, the second last sentence tells us that the robot finds the path within 10,000 steps for 757 times, which is 75.7% for 1,000 tries. And otherwise, the tries when the robot reaches to the exit over 50 steps is just 2 times, also which is 0.2% for 1,000 tries. So these values is quite different from the tries we did for the report. This is because the step is flexible, as this program decides the direction of movement randomly. And also this program direction brings the robot to visit the blocked way. So in this case, the robot needs to visit the space twice to return. So some of these cases, which are over 50,000 steps, means this worst case. So, but however, a significant number of the robots finish the maze within 10,000 steps. It means the conditions we set to optimize the path were implemented. So, to conclude, the main goal of this project is to optimize the path in the dark maze, not to find the shortest path. So the important thing is optimizing. And the darkness restricts the robot to be unable to recognize the structure of the maze. Therefore, we aim to optimize the conditions for the robot movement. As my teammate shows previously, the efficiency of this program is able to observe clearly, and also I proved the correctness of the program to optimize the path to escape the maze. Thank you.